Well, it's a cold one out there today, but we're in the shop and it's pretty nice and warm. Especially got the heater going. So today I'm working on a CertiFlat turntable. And this thing will spin with the help of your drill, and then you can go ahead and weld nice round stuff, and you don't have to keep moving that part around. But the one thing, I watched a bunch of videos on YouTube, and the one thing that everybody's always talking about is how to get this little shaft right here. And this is your turntable that you would mount your part to. Everybody's wondering, like, well, you got to get this square and everything else, you know. And, you know, as a pipe fitter, you know, what we do is we put a square up there, and then we clamp it this way, and then you take another square and you go this way with it. You know, 90 degrees off that, and make sure it's square that way and whatever, and then put a weld around here. I'm not gonna do that. There's just too much chance of having a variation, you know, just moving a little bit this and that way, whatever. And what I'd like to do is put a plug weld on the very front side of the shaft here. The way CertiFlat shows this, though, is from the face of the turntable to the first divot for your set screw right there is supposed to be 3 inches, which is pretty much, when you get done with it, is going to be completely flat. And I don't think I'm going to do that. So I'm going to do a plug weld. I will probably grind a little bevel on here, and then that way I have somewhere for the weld to go. The other thing is, I'm not sure why CertiFlat decided to say, well, we need to make this 3 inches. That might be a bare minimum measurement. I don't see a problem with it being higher. So the other thing that I could do, instead of doing a bevel, you know, you could recess this about 1/8 of an inch or so, and then you could fill that in. If you don't go over the top of that, you don't need to grind it. If you grind it, yeah, you grind it, you know, so what, no big deal. You know, but then the other thing is everybody's always complaining online. Like I said, they're like, oh man, we gotta get this flat and whatever, and that is kind of a problem. You know, you don't want this to go all wonky on you when you're welding. And it dawned on me, in one of the instructions to build the box, the inside box, the guy was talking about how, you know, if you place your shafts in there as you give it tacks and as you start to weld it up, if the shafts move, then everything is correct. This thing is really, really square. I mean, it's just on the money everywhere. So great laser cutting. I appreciate good fabbed up parts, good designs. Thing is just phenomenal. But once again, we come back to, how do you get this thing square to the shaft? So my idea is CertiFlat has given you a built-in way to do that. You don't need fancy jigs. You don't need fancy squares. I've watched about 20 different videos, and they never showed this idea. And I think what I'm going to do is I'm going to do this. So if you build this inside box with these shafts in it and they turn, this bushing right here, you know, everything is completely square, ready to go. So all you have to do is, you have a nice square edge right here, right? You have a nice square edge. All you have to do is put that on there, and then that is perfectly square. That should do everything you need to. Now, obviously, you are standing proud of that. You know, you need to bring that wheel up. And what I have in my shop is just simply some 1-inch flat stock that's 2 inches wide, 4 inches long. I use these as shims all the time. It's basically a 1, 2, 3 block, except for it's 1, 2, 4. So I tried this. It was a little short. Add in a 1/4 inch plate. There you go. I got a nice little short 1/8 inch recessed area in there. It's pretty much on the money. I'll probably clamp this down just a little bit with a C-clamp or a cowboy or some sort of vice grip. But yeah, that should be perfectly square with the shaft. So once I go ahead and weld this up, I'll come back with you, show you. We'll continue on with this here. So I have it all clamped up. Originally I said 1-inch block plus a 1/4 inch. I went with a 3/16 shim instead of a 1/4. That leaves me just about a 1/16 short right here compared to what they want for that 3-inch mark. I did grind a little bit of a bevel on there, so that way I have some place for my weld to go. If you notice, my blocks are not touching the inside of that bushing. That bushing does stand proud just a little bit, so make sure those blocks are going to the complete outside. Preferably, if you had something a little narrower, 1.5 inch stock or something, you would make these a little narrower. That way, it doesn't touch the outside and doesn't touch that bushing in there. But it is fairly flat. And being it's on both sides, it's going to be fine. We're not machining here. This is just for welding and semi-manual welding in a sense. So I will go ahead and put a plug weld in there. And then we will check it after it cools down. Make sure that shaft is perpendicular. I forgot to mention before I welded it, I did put those colors on, and those set screws are set into those divots. If you don't do that, just make sure that the shaft is at the bottom of that plate right there. If you didn't have it mocked into the outside box, just make sure that, like I said, this plate right here is on super flat surface. That way it doesn't drop through or whatever, but that is the measurement. And there is the final result. I will, like I said, I'll sand that down just real nicely and be super flat again. Got a nice high tack. When you're done, it should ring like a bell. Dinner time. And there is the finished product. Just about as straight and perpendicular as you can get to that faceplate. There you go. Flip it 180. There it is again. I won't show the rest of the build. There's plenty of videos like that. I'll just give a quick video after everything. I did take a lot more time than probably most people. I went around and I polished this up pretty good. I've been using these 3M wheels. They're just plastic. It does a really good job taking the scale off and everything. I think it's 3M. They call it a bristle disc. Yeah. Bristle disc. But anyways, so I polished that up and this up and everything. There's you can kind of see the outline, almost like if you were etching a weld. You can kind of see the outline of the weld, but for the most part, it's pretty good. About 1 rev every 40 seconds. Pretty good build. Pretty self-explanatory for the most part. Did have to file down the edges down here a little bit. Made this box a little too tight maybe. But it was just rubbing a little bit. I did see some videos online they had where guys would build the box, the outside box, separate from the inside box, and then they would try to push these bearings after everything was welded and assembled. I did the inside box first, and then I put the outside box around it, and then welded the outside box. And I think that was a little bit better of an idea. You don't need to go nuts on the welding. I just simply have 2 little welds on these tabs right here. There's 4 tabs on the underside here, and then another 2 tabs on the back. The more you weld, the more it warps. I like these plug welds, so that's a great way to do it. Same way with the inside box. I basically have nothing but heavy tabs or heavy tacks around the tabs. The more you weld, the more it warps, so I wouldn't go crazy. Big tacks can hold a lot of weight. You know, this positioner is good for like, I think 50 pounds. You know, if you're breaking this and you got just good heavy tacks on it, you're doing something wrong. But anyways, till the next project.